This lecture is for EXS 219, Principles of Human Nutrition. This is chapter 8 in the book about vitamins. So one critical point to remember about this is that this is a lengthy chapter, okay? And there are 66 slides. But the reality is that when we are even in class, that I try to provide a little insight on what I'm actually going to be testing over. So let's just contextualize it for a minute. Every person that comes in to ask a physician or a dietitian about how much of a certain vitamin or mineral they should take, a lot of times these have to be looked up on dietary reference intake guides or on recommended dietary allowances. So for example, vitamin C, around 1,000 milligrams a day should be the average for people. A lot of times these have to be looked at for specific disease processes, specific ages, specific genders. So I want you to approach this in the idea that you would really just need to kind of know what is this, like what is the function maybe of this vitamin? What food items might it come from? And what deficiency or excess do we commonly see? There are some other things that when I go through the slides and talk about, like the public health approach or some ways that we kind of deal with these deficiencies as society are important. But I would approach this as focusing on what is important from the lecture video, because in all reality, that is kind of the way I approach it in class. So I'm going to try to take all of this immense information about the vitamins and really break it down for you. We're going to go through it vitamin by vitamin and just think of those key points. The function, the foods that it may be in, and deficiency or excess, okay? So don't worry about the milligrams. Don't worry about memorizing everything on these slides. It's not really critical. Also, I try to remind the students that I don't expect you to memorize. Some of the vitamins, especially the B vitamins, have multiple names. So B9 is also folate or folic acid. I don't expect you to memorize that and be able to connect those. Just go by the name that I use when I'm discussing it, okay? That will make it a lot easier for you because that's how you'll see it on tests and quizzes. And typically the name that I use is, when lecturing, is the common name that you might hear out in public or the field, or how we refer to that. So let's first of all think about what a vitamin is. So we're starting our study of micronutrients. And so this is the first of the micros. And remember, we talked about the fact that our big thing is it doesn't provide energy, okay? And so a lot of times we try to think about the fact that vitamins are more complex structures typically than minerals. They're very complex. All the vitamins are essential, so essential to eat. Our body cannot synthesize them except vitamin D. Vitamin D is the one exception. And the reason being is we get about 80% of the vitamin D that we need from sunshine. It's actually absorbed through our skin and utilized in that way. So 14 vitamins have been discovered so far. And it's also important to know that vitamins are organic compounds, so they do contain carbon. And remember, of those like 3 things that classify something as a nutrient, vitamins hit the promote growth and development and regulate body processes. The other thing I want to talk about is the fact that we have to remember that poor nutrition is not just deficiency. It can also be taking in too much. So there will be some instances with certain vitamins that taking in too much can cause really negative side effects. So there has to be a happy balance. You can't go too little and you can't go too much. So one thing I want to talk about is with both vitamins and minerals, a lot of times they play a job called coenzyme. And so remember, we already talked about enzymes in the previous lectures, that enzymes act to make a chemical reaction in our body go faster. Well, sometimes in order for those enzymes to work in our body, they need a little friend, almost like glucose and insulin. They need a friend there in order to help out. A lot of times vitamins act as this coenzyme that really activates those enzymes to do their job. And specifically, vitamins help with the conversion of all the macronutrients to energy. So very important role in ensuring that we actually get the energy that we're eating from the macros. So if you like the charts, I do think this is helpful to think about, because remember there are the two types of vitamins, the two categories, water soluble and fat soluble. So I always try to remember that the fat soluble is ADEK, or DECA, DEKA, kind of how I learned it. And any other vitamin is a water soluble. Now this means it's all the B vitamins that we know about as of right now and vitamin C. So some things about those two specific categories that you should know. Water soluble obviously means that it dissolves in water. But if think about what we know about water, and water is constantly lost through different body processes. And so if that's the case, we know that these particular water soluble vitamins don't stay in the body long. So we constantly need to be replenishing them because they are turning over as often as the water is being lost. That also means that, say, for example, you take a ton of vitamin C to try to prevent illness. If there is a potential for toxicity, you're going to see it rather quickly, but it'll also be help to be excreted a lot faster than the fat soluble. So the reason being that fat solubles can become more toxic in the body is because they have to have fat to be absorbed and utilized. So when you take in too much of, let's say, vitamin D, what actually happens is vitamin D storage can be stored in adipocytes, or fat cells, in the body. And let's say during the winter months, you don't get as much vitamin D, okay? And so what actually happens is when you get less vitamin D, your body taps into that fat storage of vitamin D and pulls it out and utilizes it. So unfortunately, what that also means is it can take months for deficiency symptoms to show up, because your body is tapping into that additional storage. Additionally, if you consume way too much and it's stored, it can become extremely toxic for you. So fat solubles are ones that you really want to watch and not over consume or under consume. And once again, those deficiency symptoms occur much quicker in the water soluble because of that constant turnover. So if you want to watch a different video, it's about 4 minutes, to try to help emphasize some of these differences in fat soluble and water soluble. This YouTube link is super, super helpful. It's embedded in your slides. Just an additional way to learn about vitamins if you like, but I won't take time during our video lecture to do that. So we're going to go through this first with the water soluble vitamins. So remember, that is all the B vitamins and vitamin C. And remember, these are not necessarily stored, so they need to be consumed regularly, and they also need to be excreted in urine. That means there's much less of a risk for toxicity, because if we're constantly peeing out those additionals. But it also means that we need to consume these more frequently in our diet to avoid the deficiencies. Those deficiency symptoms can actually happen in a couple of days, which is really quick when it comes to nutrition. So if you think about people that take things like those emergency vitamins and things when they feel like they're being sick, sometimes I remind people that your body can only utilize so much of these water soluble vitamins. And once it's done for the day, it's done. And so really you're just kind of peeing out all of this expensive, sometimes supplementation that you're doing. So do keep that in mind. There is a threshold of what you can take. Now, as I said before, please don't memorize these together. Just recognize that there are 9 B vitamins as of right now, and we are going to take a look at some of them. And some of them we have a lot more information about, and a lot more focus on because of the deficiencies. So the first one I want to talk about is thiamine, or B1, but I'll call it thiamine. So this one is an important one for nerve function. This was the first discovered B vitamin, and it was actually discovered in Eastern countries in the world because of their dependence on rice in their diet. And I'll explain that in just a minute because it actually relates to the deficiency. So very important for nerve function and for the synthesis of those neurotransmitters, so that's signaling between neurons. We don't need it in large amounts in our body, and typically we find these in the bran layer of whole grain, enriched grains, pork, legumes, and seeds. So we're really talking green products here. The deficiency that I have in red here is the important deficiency I want you to know. It's called beriberi. And with this, we see weakness, nerve degeneration, heart changes. Because it has that role in nerve and muscle activity, of course, we would see changes in the central nervous system and the cardiac system that are reliant upon those. And as of right now, we don't really see any excess issues. People don't typically overload on thiamine. So beriberi, weak, I cannot, is what I remind my students to see. So the reason that we often associate this with rice is we have seen it commonly in regions where polished or white rice forms a major part of the diet. And so polished rice is when the rice is really well cleaned or washed before it is eaten, and it actually removes that outer layer that we already know from grains of kernel that is a really rich source of thiamine. Now it does, when you polish rice, it does extend its shelf life, it does make it taste better, but this is what happens sometimes when you do that, because you reduce the thiamine that's being taken in on that outer husk, and you might have beriberi. So a lot of times with beriberi, we actually see fatigue and weakness, so weak, I cannot, nerve disorders, mental confusion, impaired growth, and actually swelling. You can kind of see the swelling there on the foot. This can be lethal, but what's interesting about most vitamin deficiencies is a lot of times when you add the thiamine back into the diet, this all resolves itself. So beriberi, weak, I cannot, and remember that has to do with polished rice. The other one that won't be on your exam, but kind of interesting because you might actually see it in a clinical setting, is Wernicke-Korsakoff. And this is actually a type of brain damage that causes mental confusion and memory loss, and we only really see this in alcoholics. It's very, very rare except in that population, and the reason being is they replace a lot of the grains in their diet with those alcoholic products which don't have thiamine. We actually see thiamine deficiency being super, super common in alcoholic patients. And you can actually see there's a change in the brain tissue that we see. So moving on, hopefully you got those big key points about thiamine being for nerve functioning, and the fact that it is found in grain products, and that deficiency is beriberi, weak, I cannot, that impacts nerve function, and we see a lot in that polished white rice. So that kind of gives you a concept of what I'm looking for there. So let's move on, riboflavin, or B2. I always call it riboflavin. Riboflavin is important because it actually helps convert other vitamins and minerals to their active forms. So sometimes when we consume vitamins and minerals, they're actually not in the form that can be used for the body. So riboflavin acts as like a coenzyme in ensuring that we can utilize those active forms. Unfortunately, riboflavin can be destroyed by light. It is actually a yellow or green color. The Latin root word of the word flavin means yellow. And we actually know that food that is rich in riboflavin, particularly dairy, is when it's stored in glass and that sunlight comes through, it can actually destroy it. So a lot of times, I don't know how many of you guys drink Mayfield milk, but one of their key things that they say is that their milk is more nutritious. And one of those reasons, think about that yellow container. They say that yellow container actually prevents further light from coming in. Typically, we don't have to worry about it with that clear plastic on milk. But they say that it makes it more nutritious because less riboflavin is lost when sunlight hits it. So riboflavin destroyed by exposure to light. Now, we typically see this in dairy products. I want you to think about milk with riboflavin, so that example, but we can get it in leafy greens and other dairy products. The deficiency is erythroflavinosis, which is what you actually see here. So it's pretty rare, but it just basically affects the mouth, the skin, the red blood cells, and you see this scaliness, and this red cracking, and sometimes even a purple tongue with erythroflavinosis. Now, there's no toxicity that we're concerned about, but interestingly enough, if you take in way too much riboflavin, typically through supplementation, your urine will turn bright fluorescent yellow because riboflavin is naturally yellow-green. So niacin. Niacin is a coenzyme in glucose metabolism, so meaning it helps us break down carbohydrates to the energy we need. Our sources include meats, fish, peanuts, but especially whole and enriched grains, legumes, wheat bran. So we get niacin a lot of times from our green products. It's actually one of the ones that's added back in when we enrich them because we lose it with that refining process. So the reason I have a picture of corn up here is because of the deficiency pellagra. And I'll show you a picture of that in just a minute. But the story I want to tell you is that we actually found out about pellagra and niacin in Native American communities and in other populations where corn was the primary source of grain consumed, not wheat. And so we were seeing all of these strange symptoms that were associated with not having enough wheat, not having enough niacin, and recognized that that's what was missing. So those particular populations where corn is the primary grain, cornbread, maize, those types of things, we're more concerned about pellagra. So pellagra is quite serious. It can cause widespread damage because it's required for metabolic pathways, so that glucose metabolism. Pellagra is actually characterized by the 4 Ds. So it starts out as dermatitis, which you see here on the left in our friend, then diarrhea, then dementia, then death. So it's quite serious. And this, the Caucasian male that you see here in the right corner, he actually has a dermatitis rash on him that is very symptomatic of pellagra. It's called Casal's necklace. So they get like a red itchy ring on the collarbone. A lot of times people do not get this deficiency from like not having enough of it. Sometimes it can be from lack of supplementation with that if they're doing the corn grains. Now I will say you can take in too much niacin. And we actually see this in products that are sold to help like protein, pre-workout, things like that. And so the reason being behind adding niacin is too much niacin, which typically comes from supplementation, causes skin flushing and a tingling sensation all over your body. So if you think about why the supplement industry would add this particular vitamin with these side effects, the reason to me is pretty clear. It makes people feel like it's working when in reality it's just a lot of niacin. So no matter what the claims are, we actually see niacin a lot of times in these pre-workout supplements or protein supplements to build muscle, and it's really just a lot of niacin that makes people feel like it's working. Okay, so niacin, big picture, that coenzyme and glucose metabolism, grain products, and the deficiency is that pellagra with the 4 Ds. All right, so choline is actually the newest vitamin added, which is why you will see this is the only slide we have on it because it's the newest. We don't have a lot of scientific evidence on it. Actually, our food sources are all types of meats, eggs, milk, and beans. And this is required for signaling between cells and memory processes early in life. You may have noticed that some baby products have the addition of choline in them. Pantothenic acid, or B5, is very critical for coenzyme A, which is actually needed for all types of metabolism. It's absolutely required. And this one we don't really worry a lot about. Why? Because it's widely distributed in all kinds of foods, particularly meats, eggs, things like that. And so if you think about our diet, we get plenty of protein, so we really don't see a deficiency in this, and we don't see toxicity. Pyroxidine, or B6, actually helps us build proteins in red blood cells. We see this in meats, bananas, avocados, and cereals. There is an upper limit to taking this in, meaning we know at a certain point that we will see negative side effects. And in that type of negative side effects, it actually mimics the symptoms of multiple sclerosis, which those patients have hand tremors, they have abnormal walking, they're not able to complete daily living activities. It's a very, very serious thing to be experiencing, when in reality, sometimes it is just an overconsumption of pyroxidine. Biotin, I'm sure a lot of you have heard about biotin if you're females. It is widely touted as being that hair, skin, and nail supplement. It's needed for the body's manufacture of particularly fats and proteins. The deficiency is extremely rare, but naturally we get it from things such as grains, meats, eggs, dried beans, and vegetables. And as I said, this is not one that we're also worried about taking in too much or seeing toxic effects. So a big one that you'll be tested on is folate or folic acid, B9. So folate is very important because it is needed for DNA synthesis. But more importantly, it is critical for pregnant women. Early in pregnancy, the neural tube closes is about 8 weeks, and this protects the brain and the spinal cord of the fetus. Unfortunately, most women do not find out they are pregnant until they've missed a period, which would be early at 4 to 5 weeks, and sometimes, particularly if it is an unplanned pregnancy, which is about 50% of pregnancies in the United States, we're not really looking for missing our period or whatnot. So it can, women can miss it and not be taking prenatal vitamins and end up not realizing they're pregnant until after this neural tube is closed. And we'll talk about the large societal ramifications of that in just a minute. So, but that's what it is critical for in pregnant women, that neural tube closing. Our major sources typically are leafy greens, but we also find it in dairy, grains, and beer. Hopefully beer is not the main source there. So you'll hear people go between folate and folic acid. So one thing I want to be very clear about is the difference in that, because you'll hear them use it interchangeably. It's sort of interchangeable, but one important thing to note is folate is the dietary form of it. So it's what's naturally found in these food items. Folic acid is the synthetic form. So same thing, it's just been created in a lab and a lot of times added to our vitamins, like multivitamins. So this is one important number I want you to know. Women, the minimum they must take is 400 micrograms per day in order to prevent spina bifida, which is those neural tube defects that I was talking about. And so that's the really deficiency I want you to worry about. There's a lot of deficiency symptoms on here, but primarily what we see is in pregnant women, that deficiency in folate before in the first 8 weeks will potentially cause neural tube defects. And what that actually looks like, if you've never seen a baby with spina bifida, is it creates this little pouch where that neural tube doesn't close, where spinal fluid and sometimes even part of the spinal cord will sit outside of the body. These children have potentially paralysis for life, learning disabilities. They can end up developing no brain while they're developing in the womb, and die after birth. In general, children with spina bifida do not have great health outcomes, and it's lifelong issues related to this. So it's very, very important that the neural tube closes and that women are taking folate. So the reason we care about this is that in the mid-1990s, we actually saw this crazy spike in cases of spina bifida, and public health researchers could not figure out what was going on. Why are we seeing this spike? And so what was happening was kind of what I was talking about, where you have women that may not realize they're pregnant because the pregnancies are unplanned and they are not getting adequate folate from their food items. And so that is when, in the late 1990s, scientists decided to add folate to fortify grain products to ensure that all women were getting adequate folate in their diet, so that if they did become pregnant, we could reduce spina bifida. So if you look and see, we had that spike in 1995, And then in 1997, when it really started to be implemented, we saw the severe decrease over the next decade as most women were consuming adequate folate in their bread, in their cereals, in their pastas. So that is what fortified means. A lot of times when you see that a food has been fortified, particularly grains in the grocery store, one of those main things is folate. So just to be really clear, that is the public health approach. It's important to tell people individually that they need to consume grain products that are fortified with more folate. But when we see something large societally happening, we try to figure out, similar to the fluoride with the dental caries, we try to figure out how to supplement everyone's diet to try to prevent these huge public health issues. And in this case, not just is it challenging for the parents and for the child for the rest of their life, but you think about the lifelong health needs that that baby will need. And from a societal standpoint, that can be very expensive. And so it's almost like that prevention model where, okay, if we can get people to take folate, that's not very expensive to require companies to fortify with this, we can prevent all of this on the back end. All right, so B12 or cyanocobalamin. So it is by far the most complex vitamin, and part of the reason it has that like cobalt in it is cobalt is actually part of its structure. So it is really critical for ATP production from fats. It actually helps maintain that myelin like fatty coating on nerves to ensure that signals are happening. So this is one that's found naturally widely in animal products and in fortified products. The deficiency is pernicious anemia, and I'll talk about that in just a minute. I'll explain what that is. Typically, we don't really have any access that we worry about, but this is one where vegans are really at risk. And reason being, if it's found widely in animal products, we typically worry about vegans being at risk for this. So pernicious anemia actually impacts the stomach. And anemia in general is just when there's a decreased risk in red blood, or there's a decrease in red blood cells, which meaning someone doesn't get enough oxygen. So typically in this country, it's iron deficiency anemia, meaning the anemia, the lack of red blood cells to oxygenate the rest of the body, is due to a lack of iron. In this case, pernicious anemia is when there's a decrease in red blood cells because people are not getting enough B12. So in our stomach, typically we have this intrinsic factor that allows our body to absorb the vitamin B12 to assist with some of this amino acid protein metabolism and red blood cell creation. And so when our body does not have enough intrinsic factor, we can't absorb the B12, or if there's not enough B12 that you're taking in, and then thus not enough red blood cells. Leaving this untreated can cause heart and nerve damage due to the lack of red blood cells. So this is very serious, but like I said, we don't see this super frequently, but vegans are at the highest risk. Okay, so the last of the water solubles is vitamin C, and I always try to remind people these are typically our foods that we think of as being citrus or more exotic, but we do find a lot of vitamin C in leafy greens, broccoli, and things like that. Vitamin E or vitamin C is also called ascorbic acid. It's how you'll see it sometimes if you're taking it in a supplement form. It's quite critical for the synthesis and maintenance of collagen, which is the base of all connective tissue. Now, this is the first one we've seen that's an antioxidant. So it's very important to know that vitamin C is an antioxidant. And we'll talk about what an antioxidant is at the very end of this, but just note to yourself, this is one of the antioxidant vitamins. So as I said, sources, citrus fruits. A lot of times we also think of those like brightly colored vegetables. And the deficiency is scurvy. So you may have actually heard of this previously because this is the one we often think about with pirates. So that lack of availability of those fresh fruits and vegetables after being out at sea for multiple months would create these symptoms of scurvy, that pale skin, sunken eyes, loss of teeth. Typically, we don't often see this much anymore. So let's move on to the fat-soluble vitamins. So as we said before, just remember they pose a greater risk for toxicity because they're stored in the body for long periods of time, and they can be stored in the liver and in fatty tissues. So the first is vitamin A. So what's important about vitamin A is vitamin A, when it's consumed, is actually not consumed as vitamin A. It's either consumed as a retinoid or a carotenoid. So with retinoids, typically you may be familiar with those as retinol or retinoic acid, which are frequently used in the cream format to help your skin. Women may put retinol on their skin as they age because it helps with cell turnover, making you look younger. Carotenoids, on the other hand, are yellow or orange pigments that are oftentimes found on plants. So actually think of the plants that look yellow and orange, and those are likely contain beta carotene, which is that vitamin that is actually in the carotenoids that are converted into vitamin A. So it is kind of important to know that you don't actually consume vitamin A directly, but it can be in these forms: carotenoids, beta carotene, retinoids, and then it's converted in your body to vitamin A. So as I said, vitamin A helps with cell turnover and the maintenance of epithelial tissue, which would make sense as to why people would put it on their skin to prevent aging. It is also important for your eyes. And so there's a specific visual pigment in the eye, rhodopsin, that vitamin A is a critical part of, which is why you've probably heard before, eat your carrots, helps your eyes. The other thing is vitamin A is another one of our antioxidants. So just note that. So in animal products, typically we see these in eggs and dairy. And then fruits and veggies, and particularly those orange, yellow, and sometimes dark green, because the chlorophyll is actually kind of masking the beta carotene. The deficiency that's important to know, but it has a very low risk in the United States, is xerophilioma, which is actually considered to be night blindness. It is the leading cause of non-accidental blindness worldwide. Often death occurs within 1 year after having night blindness. Very serious. We see it in children in developing countries a lot of times. And too much of this actually causes hypokeratinemia. So hyper meaning too much, hyperkeratinemia meaning basically too much vitamin A in the blood. Let me show you what that looks like. So first, xerophilioma, or night blindness. A lot of times they get this cloudy look to their eye, and they're not actually able to produce that rhodopsin to help them differentiate. It also does not allow these children to produce tears, and it creates like a pathological dryness of the conjunctiva and cornea. Now, the hypokeratinemia. Typically, we see this in what we call orange babies. So these babies actually do turn orange. They take on this very sun-kissed hue, like they've had a really bad self-tanner. And what it is that a lot of times the first foods that we feed babies are orange and have those rich in beta carotene. So think about it: sweet potatoes, squashes, pumpkins, carrots, things like that. And so if parents are starting with those and doing really beta-rich carotene foods initially really early, their babies can turn orange. So we just tell them to change it up. We don't want them to do all those beta-carotene rich foods one right after the other. And this goes away if we make sure that the child, drinks a lot of fluids. It goes away. It's not a big deal. A lot of times we don't see it in adults because it takes such a massive amount of beta-carotene. But this is something that happens. Just be aware of it. So vitamin D is actually our one non-essential because it's made in the skin with exposure to ultraviolet light. It's actually an inactive form and then is modified in the liver and the kidneys. Also, vitamin D is the precursor to cholesterol synthesis. So remember, cholesterol is also non-essential. So vitamin D is critical to ensuring, getting enough vitamin D is critical to ensuring your body has enough cholesterol. As I said, at the minimum, the sun normally provides 80% of your needs, but we also call this a conditional vitamin because if you get enough, you won't need any dietary sources. But sometimes in the winter, some people go ahead and take vitamin D. They do need additional sources. So oftentimes we think about vitamin D as being critical as in relation to bone health. So vitamin D actually helps maintain normal levels of the vitamins of calcium and phosphorus in the blood. And as we know, calcium and phosphorus are critical for bone health and creation of new bone. And vitamin D actually regulates that calcium phosphorus concentration. So it's really important that someone has adequate vitamin D in addition with the calcium and the phosphorus. I almost think about them in kind of like a triad. And we'll talk more about that bone health when we talk about the calcium and phosphorus, but just remember vitamin D is a critical regulator in those two minerals. So our sources typically are animal-based products. We can get it in fortified foods, so vitamin D enriched milk. Think about that, vitamin D milk. So the deficiency is actually different in the children and adults. You actually see pretty significant bone changes. So in kids, it's called rickets. The bones often weaken and the legs bow in together. And in adults, we often see it as osteomalacia and osteoporosis. And this just has to do with poor calcification of the new bone as it's being formed because of the fact that lack of vitamin D would not regulate that calcium. And so you get these soft, spongy bones. Excess, it is important to know that if you do take in too much, you'll have high calcium concentrations in the blood, which can actually cause calcification, kidney stones, cardiovascular damage. So once again, it's not that it's vitamin D directly, it's that relationship to calcium. So not having enough, you won't have enough calcium that you need. Having too much, you'll have too much calcium in the blood. This is what rickets looks like. We saw this a lot in the early 1900s until vitamin D was added to milk. So having vitamin D and calcium in the same source ensured that if the child was getting enough milk with calcium in it, they were also getting adequate vitamin D. Okay, I think that was it. Okay, and like I said, this will make more sense when we study calcium. In general, for right now, I would know the rickets. I would know it works directly with calcium and phosphorus. I would know that milk is an important source, particularly that we fortify it. So vitamin E, this is our last antioxidant. So if you're keeping track, we had A, C, E. So ACE are our antioxidants that we talk about in this class. I often think about vitamin E as this very lubricating vitamin, function-wise. I don't know how many of you have ever seen a grandparent or something open vitamin E. It's actually in kind of like a jelly-looking pack and like put it on scars or anything, but it has anti-inflammatory functions and it defends cells and protects lipids. So it's very much, we find it in a lot of our really nourishing skin products. So I often think about it in that context. Typically we get plenty of this, but if you're not taking in healthy fats, which is really the big source of it, nuts, seeds, plant oils, wheat germ, sometimes fortified cereals, you're not going to be getting enough vitamin E. The deficiency is quite rare. It's hemolytic anemia in infants, but it's very rare, and we don't actually typically see any toxicity from foods, but large doses from supplementation can interfere with blood clotting. So lastly, of the fat solubles, vitamin K. Vitamin K is very, very critical because it is required to make blood clotting factors by the liver and convert pre-prothrombin to active prothrombin. So basically making that like scab, helping us get better. So important to know vitamin K is part of that blood clotting mechanism. With the sources, we often think about leafy greens, and this is where we're going to talk for a second about why it is extremely critical for our patients in nursing homes and long-term care facilities not to take in too many of those collard greens and turnip greens. Because a lot of our older adults often take meds such as Coumadin, or what is often called blood thinners, warfarin, taking in too much of dietary sources of vitamin K can actually keep the meds from working and the blood can start to thicken far more than it needs to. So they're taking a blood thinner because they're trying not to develop blood clots, but taking in too much vitamin K. So you may hear sometimes people that work in hospitals or people that work in long-term care facilities talking about not serving greens too frequently, and this is the reason why. With a deficiency, it's very rare, but you can maybe see some abnormal blood clotting, and typically we don't often see the toxicity as well. So let's talk antioxidants. Why do we care about antioxidants? So remember, our antioxidants are ACE, A-C-E, and antioxidants are critical because they prevent or repair damage to cells. So I don't know if you have ever thought about what an antioxidant is. We see them advertised on our things all the time, right? Like rich in antioxidants, but what actually is it? So let's think about chemical structures really quick. All right, so you have that outer electron shell, remember that? And you have electrons. Now, in order to be a happy molecule, you have to have the right number of electrons in your outer shell. If it is missing one of the electrons in its outer shell it needs, it becomes kind of radical. It does crazy things in your body. These are called free radicals. So sometimes what can happen is you can be exposed to things like environmental contaminants, toxic metals, things in our environment, pollution, and they get in your body and they're already free radicals. So they need an electron. So what happens is this cascade effect where it starts stealing electrons from your healthy body cells, okay? And as it starts to steal electrons, it then makes those healthy body cells now also free radicals because of the fact that they're not happy in their electron shell. This is the idea of oxidation in the body, okay? And so you have this cascade effect. It's actually been linked to many types of cancer long-term, inflammatory processes, autoimmune diseases. Now, what an antioxidant does, think about what that says, antioxidant, so it keeps the body from doing that oxidative process, it is a substance that actually is able to donate extra electrons from its shell to stabilize all these oxidized molecules and repair them around it. So without antioxidants, you would have this cascade effect happening of cells just losing their minds, those free radicals. If you're taking in enough A, C, and E, it is donating, if you happen to take in free radicals, it's donating electrons to those shells so that they are stable. So let's talk supplements for a minute. We've kind of already talked a little bit about supplementation, but it is important to remember that you can take a lot of these vitamins, minerals, herbs, any of that over the counter. And actually, it's really not well governed. Americans spend about $14 billion a year on all of these types of supplementation. Some of them are great. Some of them are prescribed by our doctor, were needed for deficiency. However, sometimes there's a lot of information lacking on these products. They're normally not really well governed, not in the same way that you would have a food product governed, right? And what's interesting is products that are seemingly similar next to each other on the shelf from different companies can actually have different ingredients and have fillers in them, such as gluten, and expose people with celiac disease to unnecessary items. So one thing I always remind my students is just to make sure when you're choosing supplements, think about why you're wanting to take them. Is it something your doctor's recommended? Read the label, check the expiration date. Actually, that is a huge issue in grocery stores and pharmacies. Consider the other medications you're taking. A lot of times supplements and herbals over the counter can counteract with certain medications. So for example, St. John's wort is often taken for mood elevation. It actually can prevent oral birth control pills from working. So just be really careful with some of these products and make your doctor aware with other medications you're taking. And the biggest thing is, how would I recommend to get enough vitamins? Well, that goes back to that variety concept. So considering a diet full of variety and balance, you should be able to get enough vitamins that you need. Another way to get it is through that food fortification that we've talked about. So ensuring that you're taking in some of those fortified products and some of those staple things. So optimally, I would want people to do dietary diversity. Food fortification can be a public health approach to decrease nutritional deficiencies. That biofortification is sometimes when we talk about GMOs and things, ensuring that at the agricultural stage in the process that we're eating foods that have greater amount of nutrients. And lastly would be that supplementation. For me, supplementation would potentially be like kind of like the last thing that I would consider. So I do want to talk about the fact that once again, that addition of folic acid, when we're thinking about products that are fortified or labeled as enriched, has significantly impacted babies born with spina bifida each year. And so because of that, from a public health standpoint, we are saving millions of dollars in the healthcare costs to take care of these babies, not to mention the emotional impact of it, right? You have healthy kids now. So it's important to understand that that fortification process is more of a public health societal approach compared to just recommending someone take in enough folate. So just some of the pictures we looked at, if you're wanting to review, it's really important maybe you go through here and try to identify those deficiencies with the vitamin that they match with. So those were just some ways that I thought that maybe you could study. Another important thing is to consider the fact that vitamins can be destroyed. So depending upon the structure, exposure to air, exposure to light, exposure to heat, you can actually destroy all the wonderful vitamins in your food. One example I often give is if you have Southern family at all, I have noticed we really like to cook green beans for a long time, and those green beans actually turn the water green. And when you see some of those changes in the water color for what you're cooking, a lot of times that is the good stuff leaching out. So it's important that you don't overcook foods, you consume them pretty close to the time that you're cutting them, you're not storing them in heat and light, and you're not rinsing away those wonderful thiamine sources on rice. So another good way to study is I thought I'd provide you with this table and just ensuring that you can match those vitamins with those deficiencies.